Have you ever stopped and wondered if any of this is actually real? I mean, the chair you're sitting on, the air you're breathing, even your own thoughts. It's a pretty wild idea, but it's one that's being seriously debated right now. The possibility that our entire reality is nothing more than an incredibly sophisticated computer program. So, that's the big question, isn't it? If we are inside a simulation, how in the world would we ever know? How could you test the walls of your own prison when you can't even see the bars? Well, that's the exact puzzle we're going to try and piece together today, looking at all the angles, from mind-bending philosophy to hard-nosed physics. Now, this idea has been floating around for centuries, but the modern debate, that really caught fire back in 2003 thanks to a philosopher named Nick Bostrom. He published this paper that was a total game changer. See, he wasn't trying to prove we're in a simulation. Instead, he laid out this brilliant and kind of terrifying logical trap. He called it the simulation argument, but a better way to think of it is a trilemma. You've heard of a dilemma, right? Two bad choices. Well, a trilemma gives you three possibilities, and Bostrom's argument is that logically, one of these three absolutely has to be true. And trust me, each one of them is a total mind-bender for what it means to be human. All right, so what are these three options? Option one is, well, it's pretty bleak. It's that civilizations like ours almost never survive long enough to develop the tech to run these kinds of simulations. We just go extinct. Bummer, right? Okay, option two. Maybe advanced civilizations do make it, but for whatever reason, they're just not interested in running ancestor simulations. Maybe it's an ethical no-go for them, or maybe they just find it boring. But here's the kicker. If you think those first two are unlikely, Bostrom's logic basically forces you into a corner, leaving only option three. And the logic behind that third door? It all boils down to simple math, really. Think about it. If a super advanced civilization can create simulations of their past, why would they make just one? They could run thousands, millions, maybe billions of them on their supercomputers. So suddenly, you have this picture where there's only one base or real reality, but a potentially astronomical number of simulated ones. And here comes the statistical punchline. If there are billions of simulated people living in these simulated worlds, and a much smaller number of real people in that one base reality, which one are you more likely to be? Just based on pure odds, you'd have to bet you're one of the Sims. It's an incredibly powerful argument, and it's so seductive because it's built on nothing but cold, hard logic. But, and this is a huge but, for a lot of physicists, that's exactly the problem. They look at this elegant, logical argument and say, nope. They argue this isn't science. Physicist Sabine Hossenfelder puts it really bluntly. It's not science. It's not even pseudoscience. It's just words. And right here is where this beautiful philosophical idea slams right into the brick wall of hard science. And this gets us to a really crucial distinction. For something to be a scientific theory, it has to pass some key tests. The big one is that it has to be falsifiable. That's just a fancy way of saying there must be some experiment you could do that could prove it wrong. A philosophical idea, though, that's more about logic and speculation, and you often can't disprove it. So where does the simulation hypothesis fit? Well, for most scientists, the answer is pretty clear-cut. They say the simulation hypothesis is fundamentally unfalsifiable. Think about that. There is no experiment you can design, no star you can look at, nothing you can do that could ever prove for sure that we are not in a simulation. And that's a really big problem for science. Yeah, it's basically the perfect intellectual trap. Let's say you find some weird glitch in the laws of physics, a bug in the matrix, right? A believer would just go, see, proof, it's a bug in the code. But what if you find absolutely nothing? Then they'd say, see, that just proves how perfect the simulation is. When your idea can explain literally any result, it doesn't actually predict anything. And in science, a theory that explains everything, well, it really explains nothing at all. Okay, so let's put the philosophy aside for a second. Let's get practical. Forget the logic puzzles. Let's talk physics. Could you even build a computer powerful enough to simulate our entire universe down to the last atom? Because when you start to run the numbers on that, they are absolutely staggeringly huge. So physicists tried to calculate the information density of our universe, basically how much raw data is crammed into every single cubic meter of space. The number they came up with is just insane. It's about 10 with 46 zeros after it. For perspective, the most powerful computer we can even imagine would hit a limit of maybe 10 with 27 zeros. Our universe is just on another level of complexity. And believe it or not, that's not even the biggest problem. You've got quantum mechanics, which is a nightmare to simulate. For every single particle you add, you basically have to double your computing power. It gets out of control fast. Then there's the energy bill. A real law of physics says that processing information takes energy. And to simulate our universe, you'd need more energy than our entire universe actually contains. It's a flat-out physical contradiction. So let's just boil it all down to one crucial point. The computer you would need to run a simulation of our universe would have to be bigger and more powerful than the universe itself. You can't fit the computer inside the thing it's computing. It's a paradox, and it suggests the whole idea might just be physically impossible. So for a long time, that's kind of where the debate was stuck. You had the philosophers with their compelling argument on one side, and the physicists with the physical impossibilities on the other. But very recently, a team of physicists came forward and said they've taken it to the next level. They say they've developed a mathematical proof that our universe simply cannot be a simulation, period. Okay, so their argument gets a little deep, but it's based on an idea from the famous mathematician Kurt Gödel. He showed that there are some truths out there that you can never arrive at just by following a set of rules, like an algorithm. They call this non-algorithmic understanding. A great analogy is cooking. Following a recipe step by step is an algorithm, but inventing a brand new recipe? That requires a creative leap that goes beyond any instructions. That's non-algorithmic. And that is the absolute core of their new proof. One of the authors, Dr. Mir Faisal, says their research shows that the fundamental laws of our reality seem to be based on this non-algorithmic process. But a computer simulation, by its very nature, is an algorithm. It's just a bunch of code following a pre-written set of rules. You see where this is going, right? If the bedrock of reality itself is built on something that can't be computed by an algorithm, then an algorithm could never, ever replicate it. It's like trying to write a recipe for creativity itself. You just can't do it. And this argument strikes right at the very foundation of the whole simulation idea. Okay, let's zoom out and look at the scoreboard. In the fore corner, you've got Bostrom's trilemma, a really slick statistical argument. And some say it's a neat way to explain some of the weirdness of quantum physics. But then you look at the against corner and wow, the list is pretty long. We've seen that it's unscientific, because you can't prove it wrong. It seems to be computationally and physically impossible. And now some even say it's mathematically impossible. It really has a mountain of objections stacked against it. So, at the end of the day, where does that leave us? Look, the simulation hypothesis is an amazing thought experiment. It's one of those ideas that really pushes you to think about reality and consciousness. It's brilliant. But when you look at the actual science, it just doesn't seem to hold up. It's destined to stay a fascinating question for philosophers, but it's not looking like a reality for physicists. And maybe that leaves us with an even bigger question. As we try to figure out our place in the cosmos, how do we draw the line? What's the difference between a truly groundbreaking scientific idea and just a really, really cool story? Where that boundary lies? Well, that's something worth thinking about.